Can you guys all see Canvas here? So if you, let's see. Okay. I put the updated homework timeline sheet up there. So you probably want to take a look at that sucker. I don't think it changed too much from, I kind of previewed it yesterday for you. I said I just needed to firm up a couple things, and I did that. So now it's up there. I don't know if you guys can see that now, the Math 90 timeline homework. Did you guys see that? So it's up on Canvas. It's got the dates for all the remaining quizzes. It's got the final exam dates. It's got all that kind of stuff. I put 2 days worth of review for the final exam in there. Okay. So it's up there if you want to take a look at it. It's got chapter 8, chapter 9 homework, blah, blah, blah. So that's up on Canvas in the announcements. So it should be something you guys can see. Let me see here. What's going on? Okay. All right. So any questions on that? So that's up there.
Where is it? Excuse me?
All right. Let me show you again.
Please.
It's an announcement on Canvas. So it should be like one of the major things you see. So let me see. Let me do student view here. Crappity doodah. Don't want a new announcement. Go away. All right. Don't shift around screen. Okay. So when you log into Canvas, up here is announcements.
Okay.
Yep. So updated homework timeline sheet. There's all kinds of other nifty announcements too. Like I'm going to put the Zoom lectures link up there and stuff like that.
You got it.
Okay. So if you click right here, you can download your own copy. You can keep track of what the hell we're going to be doing. I like it. Okay. Let me close some stuff here. Got too much stuff open.
Thank
All right.
you.
Oop.
Oh my God.
Okay. Does anybody have any questions from homework before we get back into where we left off? Why so far down here? Any questions? No? Everybody's all right? All right. So we're going to continue our yes. Is that a yes, you're okay? Or yes, you have questions? I guess that's a yes, you're okay. Or do you have a question, Youngsha? You're good. Everybody good? All right. Okay. Getting back, that means each of these combinations, wait a minute, I'm not sure. What do you mean? Each of these combinations is not an option. What is it we're talking about, Yangsha? I don't understand.
Yeah.
What are we talking about? Sorry. What combinations of what? I'm sorry.
Yes, I have a question.
Say, I'm sorry? I can't make you out here. What's going on? Is it my internet connection or what's going on? Are you? Yangsha, you're gonna have to type it because I think your computer is wrong. Okay. I'm not sure what to do for you. Hopefully get that figured out. Okay, all right. When you get back, just let me know what the question is. You can type it in. I'm not sure what that means. Okay. I think you're frozen, Yangsha. All right, I'm gonna move on. Just if you can, type in a question or something. I'm not sure what that means. The combinations. I don't know what that means. This is a fabulous way to communicate. I got to tell you. All right. I got to keep going. All right. So let's get back into where we left off. Okay. Everything all right? You okay? You actually look a little more mobile. Okay. All right. All right. So, I'm not going to do, let me see, here it is. Oh, geez. I'm not, what are we even looking at, Youngsha? Help me out. What are we looking at? The trinomial has no common factors. Then neither factor can contain a common factor. That means each of these combinations is not an option. I have no idea. You could have, so we have factored things that have no common factor. We have, right? We definitely have. So I'm not really sure what your question is. I can't interpret it. So, I mean,
Yeah, I thought our
no, you can't talk. It's too choppy.
I don't know what yeah, I can't understand it.
I can't understand you at all. Your connection is too choppy. Hopefully it's not mine. I think I'm okay.
Yeah.
Okay. All right. All right. All right. I don't know what's happening. I can't understand you. I can't understand you. So you're going to have to type. Okay. Give me an example problem that we're talking about or something. I'm not sure what we're talking about. Okay, I got to keep going. Okay. All right. So if I had something like this, right? So if I had this, does it have any common factors? No.
No.
Good, but I can still factor it, right? Yes. Okay. So I guess that's not your question. So I don't know what your question is. How do I do this problem? We did this problem the other day. What does it break down into? What kind of number puzzle does it break into? I need two numbers that do what? Anybody? What? I need two numbers that do what? Yoshi, you got to give up on talking because your connection isn't good enough for audio.
And
Your connection's not good enough for audio, Youngsha. You got to give up on talking. Yeah, add to 8 and multiply to 12. Yes. I don't know. You might want to reboot your modem or something later. I don't know. All right, let me stop right here for a second. So yesterday we sort of focused on GCF, right? And then we did some grouping stuff, okay? And I asked everybody, please, dear God, do section 7.1, come ready with questions. Nobody's asking any questions, so I must assume that means everything's great. You got to let me know that's not true. Now we did a decent number of these kind of problems the day before yesterday. And we went over why they work the way they do. We looked at several examples about why they work the way they do, right? So I know it's going to come from something like this: two binomials multiplied together, right? And I know that that's x squared, so it's got to be x times x is x squared. So now it just becomes a number puzzle. What are the two numbers that go here that make these two things work? And they have to add to 8 multiply to 12. So what do we know adds to 8 and multiplies to be 12? Yeah. Right? 6 and 2. What's are you guys all right? Let's check in. Let's have a little mental health check in. You guys doing all right? Are you guys out there? Are you guys doing okay? I can't. I know this is weird. I know it's not what any of us wanted. Any of this.
I got it.
But I can't do my job well without some kind of interaction. I can't guess all the time about what you're getting, what you're not getting. I need some kind of sign to know what I need to focus more on. Like yesterday, just kind of was lucky that I noticed that we were having some trouble with GCF. So I went back and we did some GCF problems. It's fine. It's nothing wrong with that. Factoring is huge. The whole next chapter is based on factoring. So don't think they just live in this chapter. They're every damn where. So we need to get them down. So I don't mind spending a little more time on them, but you got to work with me. Okay. So let's see. Do we want to try to remember why these work the way they do? Do we need to do that? Would anybody like to see another explanation about why these work the way they do? Does anybody need that? Okay, let's do this. How many of you guys can hear me right now? Click yes.
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 Click yes. I love you guys. I love you guys so much. Okay. All right. There are people that aren't clicking it. Somebody says they want a refresher. Okay, I could do a refresher. Okay, I like that. I'm concerned about a few people not really being here. I can see Samir, so I know you're here, Mom. And so, but Lionel, Jose. All right. So I'm just gonna keep going. All right. Please mute yourself if you're not talking. I'll mute you for you. There we go. All right. So screw that problem for right now. Let's go back. Okay. Do that problem. Multiply that out. Thanks, Lino. Just take a minute and multiply that problem out. That's from the last chapter before the one we're in. Foil those out, right? Just go ahead and do it. Right? So I get x times x is x squared. X times 5.
5x.
And then the 4 gets a turn.
4x plus 20.
Right, because those are like terms. Now, the thing about math that is difficult to get, but it's actually almost just about the most important thing about math is that it finds patterns and creates ways to predict things using those patterns. That's one of the most basic things about math. Sometimes people say math is all about patterns. It's not all about patterns, but it is a huge part of it. Where did that 9 come from based on the original? Just where the 9 come from up here? Why is it a 9? Because 4 plus 5 is 9, right? In fact, you can see 4 plus 5 is 9. You can see that. So whatever numbers are here, if that's 1x and 1x, whatever numbers are here will add to be the middle term. Where'd 20 come from? 4
Multiply 5.
times 5. So whatever number is here would come from this number times that number, right? And I could, in fact, let's do it again. Just so you know, it's not, I didn't pick the one that it works for, right? So 4 plus 5 is 9. 4 times 5 is 20. Let's do another one. Right? We'll do another one. DJJ. All right, so x minus 7, x plus 3. All right, so let's do this one together. So I get x squared plus 3x. Oops, somebody's coming in. And then the negative 7 gets a turn, minus 7x minus 21. There's somebody else is coming in. All right. What time is it? Okay, sure. And then the middle terms I can put together, 3 minus 7. So again, did the negative 4 come from the same place? Yeah, it came from that number plus that number. Negative 7 plus 3 is negative 4. Did that come from the same place? That number times that number, yes. So don't, now keep that in your head. Keep that in your head. It doesn't matter what numbers are put there. It's going to always kind of come out the same way, right? So then we say, all right, let's make a puzzle out of this. What if I had, what you got, Jeff? X squared plus 9x plus 8c. Sure. Right? Can you guys see that all right? Let's bring you over here. So then, now I want to go backwards. I want to go backwards. And I know that these two numbers must add to be this. So they must add to be this. And these two numbers must multiply to be this. So these two, whatever the hell they are, they have to add to be 9 and multiply to be 18. Because that's a 1, because it came from x plus something, right? It came from that form. I know that from observations. Going this way and noticing things, I can now try to figure out, if I start here, if I start at the end, can I figure out where it came from? So what two numbers add to 9 and multiply to be 18? There's not that many. How do you break 18 up? 2 times 9, that's no good. That would make 11.
6 times 3.
6 times 3, and then 6 plus 3 is 9. Yep, see? So it'll be 6 and 3. So again, there's nothing magic about it. There's nothing, no. Is it like really easy? Not necessarily. If the numbers get big, this is going to be gross. But will the idea, if this is a 1 right there, if that's a 1, will the idea ever change? No. Because it will always have come from the same kind of place. Now, it's possible the answer could be prime, but the method I use to try to get the answer won't change. Okay, so let's try another one. It doesn't really matter what the letter is either. So if I put m squared plus 6m minus 16, sure. So what do I need? I need two numbers that add to be what?
Six.
They
8.
add to be 6.
8 minus 2.
Stop it, stop. They had to be 6, and they have to multiply to be
2.
negative 16. Come on, you can do it. You got to pay attention to the question I'm asking.
I do it already.
I know.
6, 6, 8, and 2.
I know. But it's more important right now for me to teach the idea. I don't care about the answer. To be really honest, this is such a weird thing for you to hear. I don't give a shit about the answer. I want the answer. The answer would be great, but right now, the most important thing in class is the idea. It's always nice to get the answer. Yes, it's definitely a good thing to get the answer. If you don't get the right answer, you're going to lose points, but you're going to lose a hell of a lot more points if I don't think that you know the idea. If you know the idea and you make a simple arithmetic mistake, like you're like 4 times 2 is 6, I'm not going to take a ton of points off if you can show me that you understand the idea. So it's always nice to get the answer, but the idea is more important. So yeah, they add to 6, multiply to be negative 16. Now I can take it. Hayam, what you got for me?
8 and 2.
Okay.
8 minus 2.
I'm sorry, I don't mean to come down on you or something, but don't give me the answer when I'm not asking for the answer. I'm trying to explain an idea.
Plus 8 minus 2.
Why is the 8 positive?
Yes. No, sorry.
No. You just tell me why.
Yeah. Because the minus, we have to put the minus in the last number.
Yeah,
Because
it's got to
we
be opposite signs, right?
Yes.
And the bigger one has to be positive.
The positive,
It has
yes.
to be positive. Okay.
Yes.
Okay. So 8 minus 2 is 6, and 8 times negative
Multiply 2
negative
is 16.
Yes. Kabam. So please, part of mathematics is trying to see the pattern that got us to the method we use. Then you use the method to do the problem. We kind of have verified this method works, and now we're going to use it, right? And then you can focus on the fact that this is a number puzzle. This is just, can you go back? Yes, sure. All right, let's go back to my original problem. I'm not asking for the answer. I need, what can I write down right here? What goes here? Now I'm asking for this, sorry?
X.
X, I like it. And what goes there?
X.
X, because it's X times X is X squared. That much I know. Now I need 2 numbers that add to
8.
8 and multiply to be 12. I like it. And I think somebody said that earlier. What adds to 8 multiplies to be 12?
6.
Positive 8.
No. If they have to add to 8, there's no way that one of them can be 8. The other one's 0.
Yes, I got it. Positive 6 and positive 2.
Yeah.
And 6 multiply 2 is 12.
Right? And real quick, doesn't 1 plus 7 make 8? Yeah, but does 1 times 7 also make 12? No. So you need 2 numbers that add to 8 and multiply to be 12. I don't care how you get like one of them to work and then check the other one. So what multiplies to 12? 3 times 4. What's 3 plus 4? 7. Shit. Right? 2 times 6 makes 12. 2 plus 6 is 8. Yes, got it. And then you fill them in and then you're done. So when is it that a trinomial is that simple? And I am going to say the word simple because it is a number puzzle. When the first number is a 1. Okay. Now, it's not always simple because if I make these numbers big, things get a little worse. They just do. Bigger numbers, we got too many factors, holy shit. So let's try one that's got a little bit more going on. See if Jeff can make one up in his head. Oh, here we go. Sure. X squared plus 40x plus. What do you got, buddy? I don't know. Shit, why'd I have to do that? Oh, let's do, sure, this isn't too bad. Don't say the answer. Don't chat the answer. Just try to do it. And sometimes it's go for the easy answer first. And then that if that doesn't work, you just go, oh shit, I got to think about this now. What's the easiest way to factor 300? Or what's one of the easiest ways? Since it ends in 0. Anybody? What's one of the easiest way to factor 300 because it ends in 0? Yeah, okay. So 300. So 300 is 30 times 10, right? And what's 30 plus 10?
40.
40. So I'm done. I'm done. I just got to write it. I'm done. I just got to write it down, right? X squared is X and X. And now I figured out that 300 is 30 and 10, and they both have to be positive. Done. Okay. Okay. All right. So how about let's try one with a negative in it. Oops. Let's do let's see. Yeah. So when I see this kind of problem, I say to myself, okay, there's a 1 out front. There's no GCF. So let me go ahead and do X, X. That much I know for sure. And now I can focus on what I don't know. Now this one's not as obvious. 32 and 10 don't work here, right? So if I write down negative 320, I need two numbers that multiply to be 320. So I go ahead and try 32 times 10. But that's never going to make 4. I don't care which one of them is negative, right? You guys, is anybody not with me there? You guys see what I'm saying? I said try the easy one first. Did the easy one work on this one? No, damn. Okay, now we got to really think. Shit.
40, 80.
Do it 4 and 80?
Yeah.
All right, so 4 and 80. Do they add to be
40, 40. Oh,
40,
no.
40 and 8?
Yeah, yeah.
Do they add to be 4? If one of yeah. No, it's fine. I like it, right? Okay. So this is why I like to teach very early on that it doesn't matter which thing you make work first. I really, do you guys understand? The little list that I'm making over there is making the multiplication work. Does that make sense? 320. I'm trying to make 320 work, and I'm putting some stuff down. Okay, right? Is everybody with me? But what's the other thing that has to happen? The two numbers have to multiply to be negative 320, and they also have to the two numbers have to multiply to be 320, and they also have to add up to be, oh, there it is, negative 4. Thanks, Curtis.
-4.
So let's start there. Much easier to make numbers that add up to be negative 4, right? Are they going to be the same sign? No, they're going to be different signs, right? So I'll start us off. What adds up to be negative 4? Let's see. Negative 10 and 6. Doesn't that add up to be negative 4? Oh, Melissa's got the answer. All right, Melissa. But that multiplies to be negative 60. So please, I really want you guys to understand. I just need two numbers that do two things. We all have to be good with that now. We've seen it a couple times why that is my focus. Who cares which thing you make work first? You then check to see if the other, if it doesn't work, oh shit, you go back. And then you check, oh shit, and then you go back. So let me get my way up to what Melissa's saying. So I don't have to make them multiply to be 320 first. Good Lord, that would be a long ass list. It's actually a little bit easier to make them add to be -4. -10 and 6 add to be -4, but they only multiply to be 60. So let me try 14 and 10. That multiplies to be 140. I'm getting closer, right? So sure enough, if I keep going and get to -20 and 16, that multiplies to be -320. Check. So the answer would be +20 -16, or the other way around. It doesn't really matter. So I think a part of students' opposition to this.
minus 20.
Oh, did I put +20? I did.
Minus 20, yeah.
Yeah, I have it right down there. And of course, I wrote it wrong up there. Thank you. One of students' oppositions to this is they don't believe that an algebra problem can become a numbers problem. And that's exactly what we've got here. It's just a number puzzle. And again, I know you wouldn't voluntarily choose to do number puzzles. But if you had algebra to do and they were really just number puzzles, yeah, please, yeah. You want to do long division of polynomials, or do you want to do number puzzles? All right. I want somebody to say long division of polynomials, please. Okay. Let's try another. This try one's not quite as crazy. Let's try one a little more down to earth. Let me see. I forget what number I'm on. I'll say I'm on 5. I don't know. A squared minus 2a minus, what is it, Jeff? 48. When the night has come. So first off, to be honest, the real way to do this is there a GCF in this? Is there a GCF in these three? Is there something that comes out of each of these?
Yes, it's a GCF.
What would the GCF be?
The greatest common.
No, so GCF means it's something that can come out of each. This guy has no numbers and this guy has no A's. So is there something that can come out of all of those? No. Okay. So always try GCF first, just in case. But there's a 1 here. This guy didn't have any A's. So they don't share anything. They don't all three share something. There's not something I can pull out. So kind of rule that out first. Now, what can I put here and here?
A.
Yeah, because A times A squared. So now it just becomes what numbers go in. So now that's the number puzzle. I need two numbers that add up to be what?
-2.
-2. And multiply to be?
-48.
-48.
-8 plus 6.
Yeah, so I made this one not so bad. It's not 320, it's 48. So you can actually think about the factors a little bit easier. And sure enough, 8 times 6 is 48. And like Samir said, if you make the 8 negative, so I know it's 8 and 6 multiply to 48, and they're 2 apart. And if the 8 is negative, they'll add up to be a negative. Okay. So these are problems you can attack. You don't just guess and hope. You can attack them. So in mathematics, that's what you want to discover is the method to attack a problem, right? So you don't feel like you're on the defensive. You're on the offensive. You got this numbers problem. Oh, geez. You guys with me? All right, I like it.
Yeah.
Somebody's at my door. It's freaking me out. Hold on. Oh. All right, all good. Neighbors just dropped something else. Okay. All right, so let me give you one to try by yourself. I won't say a word. Don't say anything. Don't chat anything. Just give it a try. Try to factor that. All right. Who's got the right answer? What are the numbers that work? Anybody? Yeah. Yeah. They have to multiply to be 36. They're going to be different signs, right? So they have to be 5 apart. So 9 and 4 multiply to be 36. And if I make the 4 negative, they add to be 5. I like it. All right, let's do one more. I'm going to tell you ahead of time that that this one's tricky. This next one. So we got this one. Hey, little person. All right. What you got, Jeff?
Five and two. Five. I'm sorry. Okay. I confused.
So you need two numbers that multiply to be what?
30.
30. So they multiply to be 30. And they add to be
Okay.
7. Right? I told you it's going to be tricky. Now, somebody can think it's not really tricky. What about 10 and 3? Does that work? What's 10 times 3?
No,
30.
there is minus here.
Wouldn't one of them have to be negative? Yes. And then would they still multiply to be positive 30?
Yes.
No. So what is the answer to this?
Prime.
Yes.
Prime.
Prime.
In fact, to really be prime, you got to check everything. 3 and 10 don't work. 5 and 6 don't work. 15 and 2 don't work. Yes? I like it. Now, to be completely honest, there is a way to do this, but we would not use integers. We would use irrational numbers. And we're not going to do that. Not yet. So when I say prime, I mean prime using integers, using whole numbers and negatives, right? We don't want to have to use 5 minus the square root of 7 or something crazy, right? Do you want to use that? If you do, special place in my heart for you, but we're not going to. Okay, maybe. So the answer will sometimes be prime. Now, there's one kind of problem that I want to address. I feel like maybe I can address it now. And some of you guys have already asked me about it, which is good. I always like it when I get questions from homework that kind of lets me know, oh, somebody's doing that homework. Something like this. What you got, Jeff? Let's not make it too freaky. Yeah. All right. There's obviously it's a different beast, isn't it? Is it a different beast? Oh, God, Jeff. What horrible. I apologize to whatever accent that was supposed to be. So now watch this. What's different here? How is this one different from all the other ones we did today?
And the middle term has a y, 2.
Yeah, and the last term does too, doesn't it? Shit. So now watch. Forget about all of them for a second. Can you do this problem? What is it? What do you get? This one's kind of nice. What's almost the only way to do 15, really? How do you break up 15?
-3 and a 5.
So 3 and 5. And then the bigger one's got to be positive. I like it. So anybody not with me on that? And you're all like, that's nice. You're the teacher and all that kind of shit. You can change the problem anytime you want to, Jeff. Well, now watch. Let's go back up to this guy. These are almost the same problem. Do you see that? This has just got some y shit thrown in there. So watch. The coefficients still work the same way, don't they? It's still going to be 3 and 5. But now how do I make y squared? Do you see that? Why did we put x to make x squared? To make y squared, don't I need y at the end? X at the beginning, y at the end. So you don't necessarily write this problem down, but you think this problem and you focus on the numbers and then you just add in the same way you threw x and x. And now I'm going to throw y at the end, y at the end. Maybe? And do you see how the middle terms, -3xy plus 5xy is 2xy. That's why that's got to be there also. So there's 2 of them, 1 of them, 2 of them, 1 of them. Maybe. Okay, I'm going to push my luck here. We're going to do one more kind of freaky one. I'm not even sure if this kind's in the homework. And apparently, I don't care. Here we go. Now, how's this one different? This one's definitely different, right? How's it different? Uh-oh, did my internet give up? Somebody still out there? Can you guys still see me?
Yes.
All right, just
6.
nobody wants to say anything.
No?
Isn't that a higher power?
X squared, X squared.
Yeah. So to break up x to the fourth, x squared now, right?
And 7 plus 7, plus 6 plus 2.
Nope, 6 and 2 don't make 7.
3, 4.
3, 4.
Oh, yeah.
Stay with me,
Wait.
stay with me, stay with me. Stay with me. You see how the middle term had to be x squared because I get 3x squared, 4x squared. And of course, these were from this. So do you see, if I would have done this instead, I know you probably can't, well, yes, you can see this. If I would have said this, that is prime. Because the middle power is not half of the first power. Because what's the first step that we do? Don't we take this and break it in half? Stay with me. You can do this. I do this. I break that in half. And then, of course, that is what the middle term is going to have. The middle term has to have half of that because that's where it would come from. That is prime. Because that's not half of this. So if I had a 10th power here, what would have to be there? If I had a 10th power here, what would have to be there?
5th.
Say one more time.
5.
5th power, yes. Just half a 10. Half a 10. In fact, let's do it. Let's do it. So what if I had
X to the 10th? What was it? Plus 7, x to the 5th, plus 12. What would be your first step? X10 is x5, x5. And we already know 12 and 7 is 3 and 4, right? And see how you get 3x5 plus 4x to the 5th is 7x to the 5th. So that is, if that power is half of that power, it might work.
Yes.
If that power is not half of that power, something's wrong. Okay, I like it. Let me see. Okay, good. So I'm going to try. Let's see. Okay, I'm going to push my luck here. Here we go. We're going to get back into what we were doing. Could you please give an example? Yes, exactly. Thank you. I had to work my way back up to it, Youngsha. I think I'm there again. Okay. You have desperately got to do the homework and have some specific questions ready. I know some of you guys have gotten ahead of the homework. Great, great. That's fantastic. Just hang out. I need everybody with me. Okay. So coming back to the last thing we did. And it is a rather freaky thing. So before we started talking about this, like Youngsha's saying, it's called the AC method. Before we started talking about that, we had no way to do this because the method I was just using has to have what be true before I could do it. It has to have a 1 there. Can I take a 4 out of this? Can I take a 4 out of this?
No.
No. So there's no way to make this in a form that I can use the method we were doing before. Or at least nowhere near any nice way. Let me say it like that.
It's going to be 2x.
Could be, but it could be 4x and x, couldn't it? Do you guys see that? So this could be 2x and 2x, or it could be 4x and x, and then this could be 6 and 1, or 2 and 3, or 3 and 2, and 1 and 6, and which one of them could be negative, and the other one could be positive, and one of them could be over there. All right. So right now, I just need you to recognize for me that we can't use the method we were using before. We can't, because whatever that number is, it's going to mess with these numbers. So let's do this. We're going to do that problem. I'm going to put it over there. Don't worry. We're going to do that problem before I let you out of here. Or, you know, you could leave anytime you want to and just say, my internet died. But don't do that. So let me do some more motivation like we did the other day. Okay. And again, I know this gets really weird. What I'm trying to do when we do these, when I multiply stuff, trying to get motivation for how to unmultiply stuff. We're just trying to notice patterns or things that happen that I can use to work backwards. That's what we're trying to do when I'm doing this weird shit. Take a minute and FOIL that out. Don't say anything. Don't type anything. Just FOIL it out. Oops, sorry. Let's see if my red's working. Come on, red. Let me catch up to you. Woo. So I get 10x squared plus 15x plus 8x
12.
plus 12. I like it. So I get 10x squared plus 23x plus 12. Now, let's notice some stuff. What is 10 times 12?
120.
120. What is 15 times 8?
Also 120.
120. Now, if you don't believe me, just take a second, make sure you trust me. This is on that sheet we were working on the other day. We did these already. But how the hell can I use this then? If somebody gives me this, what I do is I multiply this number times that number, and then I find factors of 120 that add to be the middle term. So when the first number is not a 1, that is how I modify what I'm doing. So let me show you. Let's do that problem I put up there. Okay. Let me show you. So everybody got what they want from this? It's going to go away. It's gone. It's gone. It's leaving. It's headed out. Okay. So look at this guy. So I can't take that 4 out. So what do I do? 4 times -6 is -24. What factors of -24 add to be -5?
3 and the -8.
Yes, right? 3 and -8. Multiply to be -24 and add to be -5, right? So then, now here's another part of what's different. 4x squared, I'm going to put -8x plus 3x minus. I want you to really see this. Look, all I did was I used these to rewrite the middle. So I used the numbers that I got from doing this to break the middle up. Why the shit would I do that? Because how many terms are now there?
4.
4. And even if you don't quite get grouping yet, it is basically the easiest form of factoring. So if I can make a problem become a grouping problem, that's a good thing. I'm like, oh, sweet. Because now, if I look at these two and these two, what comes out of these two here?
4x.
Yeah, I can take a 4 out and an x.
Cute. Cute. No?
What's left here?
Oh, it's not minus.
I'm not there yet.
X.
There's an x there, right? Minus 2. What comes out of these two?
3.
How do we know I'm on the right track? This is from yesterday. We definitely did a bunch of these.
They both have x minus 2.
Yes, that's how I know I'm on the right track. And so since they both have x minus 2, it can come out. Do you see how it ended up not being 2x and 2x? It ended up being 1x and 4x. Thankfully, if I do this process, everything's going to fall into the right place. The other way to do this problem is just to guess until you go insane. So hopefully you appreciate this process. Let me see. I got time. Let's do one more real quick, and then we'll call it a day. All right, so everybody got what they want from that? I'm going to assume that's a yes. Okay. All right, nobody's screaming at me. Okay. It's because everybody's sleeping. Oh, damn. Let me see. What else can we do? Let's do. Yeah, okay, that should work, right? Yeah. All right. So what's the first step on this problem?
Find 8 multiply -5.
Yep. 8 times -5 is -40. And then what factors of -40 add to be -6? I think we saw that earlier. We stop for a minute. When the first number is not a 1, the process will be more difficult. That should actually kind of make sense. I have to multiply that by the last dude. And that, instead of finding factors of 5 that add to be 6, I find factors of 40, -40, that add to be -6. When the first number is not a 1, I have to do this process. Then I use this to break this up. So this stays the same. This becomes -10x plus 4x. Isn't -10x plus 4x -6x? So actually, what did I just do? I just did nothing. I did nothing at all. That still is -6x there, right? Still is. So I really did nothing, which is why it was legal. But now I have 4 terms, though. So at least in that respect, I did something. Now, this is kind of interesting, too. I didn't even mean to make this happen, and this is perfect. All right, so first step, multiply A times C. The first times the last. Find factors of that add to be the middle term, and then rewrite the middle term. So now I've got a grouping problem. What comes out of these two?
2x.
Nothing.
2.
X.
8
4x.
divided by 2 is 4. I got 1x minus.
-5.
Good. Now watch this. What comes out of these two?
This.
Just leave it there.
Say again, sorry?
Just leave it there. It's
Yeah, I got one thing better. I agree with you, Youngsha. You should probably be able to do that. But watch this. If nothing comes out, something does come out. What always comes out? 1.
1.
And the only reason I do that is so it looks the same as I'm used to, right? Are these the same? Yes. So therefore, I can take it out. And then what am I left with? 2x plus 1. How do you check yourself? You multiply this back out and make sure it becomes this. Oh boy. So don't forget, I mean, I put that sheet up on Canvas and I showed you where it's on the pages one. That's the one we started looking at the other day. That's got the motivation behind why this works. It's got a worked out example and then it's got a few problems. So now we caught back up to section 7.3. Anybody have any questions, concerns? In case you joined class after I said this, go to Canvas. In the announcements, I've put the updated homework sheet. It shows all the rest of the quizzes. It shows chapter 8 and 9 homework, all that good stuff. Okay, so then you can get ahead if you want to, or you can, right? Okay, anybody have questions or comments or concerns? If not, you guys can head out. It's basically past time.
Thank you.
Thank you. We can make it through this, guys. We really can.
Bye-bye.
Bye, guys. Stay safe. Stay healthy.
You too.
Wear your mask.
You too. Bye-bye.
Yes, ma'am. All right. Bye, guys.